We're not demonstrating battery maintenance on our own batteries because, as you can see, we've just gotten a brand new bank of AGM batteries which are sealed and you can't check the water on and really don't need to be equalized. Since we have the sealed AGM batteries, our friends Jean and Pauline have been kind enough to let us use their fifth wheel to demonstrate how to service flooded lead-acid batteries. Here are the supplies you'll need to get started. A battery hydrometer, a pair of old gloves, some distilled water, and a cup to put the water into the batteries. And depending on the condition of your batteries, you may also need some supplies to clean and protect it. One note about the hydrometer. Get yourself a good one. The tall hydrometer with a single float is the right way to go to get an accurate reading on the electrolyte level. Stay away from the cheap ones with the little balls floating in them. They don't tell you exactly what your battery condition is. If you have a lot of corrosion on top of the battery cleaner and acid detector is a handy product that we pick up at Walmart. It sprays on yellow and turns pink to show that there's corrosion or acid present. As an alternative, you can use baking soda mixed up with water into a paste, and that will neutralize acid also. You'll also want some sort of corrosion preventative to keep that corrosion and acid from building up on the outside of the battery after you've cleaned it. Before we check the batteries, we want to turn off the power at the pedestal. We don't want the charger running while we are checking the batteries. If you have solar panels, either do this when the sun is not out, when you're parked underneath something to block the sun, or cover the solar panels up, or if you are able to, switch them off. We don't want any power coming into the batteries while we are checking them. We also don't want any draw coming off the batteries, so turn off your appliances like your refrigerator, any 12-volt lights. What we want to do is check our batteries when they're at rest. And what at rest means is that there is no power coming in and no power going out. And we let them sit at rest for about 30 to 60 minutes prior to taking hydrometer readings to try to get as accurate a reading as possible. This battery bank is pretty typical for an RV, which is 4 6-volt golf cart batteries wired in series parallel. It's simply the equivalent of 2 big 12-volt batteries wired together. And these are deep cycle golf cart batteries like most RVs use. They're designed to be discharged and recharged on a regular basis. The first thing we want to look at is how clean are the batteries. And you can see that these are in good shape. We're looking for that white fuzz that you see built up on the outside of highly corroded batteries. That's what we don't want. The only spot on these batteries that requires any special attention is right here on this post. You can see there's corrosion on the terminal. This is exactly what the battery acid detector is designed to remove, and it will turn pink when it hits that corrosion. One note about using the battery cleaner and acid detector. It can only be used when batteries are located in a place that's appropriate for rinsing them off with the hose after using this product. If your batteries are in an enclosed compartment that you can't flood with water, use a wire brush on the terminals instead. Either way, apply battery corrosion preventative like this red spray after cleaning the terminal to prevent it from getting corroded again. Simply follow the directions on the cans after adjusting the water level in each cell as needed. It's important to check every cell. It's also important to wear either rubber gloves or old gloves that you don't mind losing if you get a little battery acid on them, because you probably will, and next time you go to use those gloves, they're probably going to have holes in them. Also important to wear eye protection while you're doing this. You can see the scale on hydrometer that we have a green section, a white section, and a red section. Now the red section is a little faded because this hydrometer is several years old. You can see that the 1275 line is right in the green. 1278 is a fully charged, healthy battery. But you're going to see when we take our readings, if they're where they should be, they're going to be right near that 1275 line. Couple of quick notes about taking your hydrometer readings. Number one, wear gloves and eye protection. And the second thing is to take your readings prior to adding water. Taking an electrolyte reading is very easy. Just put the front of the hydrometer down into one of the cells, squeeze the bulb on top, and simply draw electrolyte up into the hydrometer. Very important that you get approximately the right amount of electrolyte up into the hydrometer. If the top of the float hits against the top of the tube, there's a stopper in there that will prevent it from floating freely. And if you don't get enough electrolyte in the tube, the float won't float. And we can clearly see that we have a perfectly charged and healthy cell. That is exactly where it's supposed to be. Now simply squeeze the bulb at the top of the hydrometer and put the acid back in the cell that you got it from. Never transfer electrolyte from one cell to another. Now move on to the next cell and repeat the process. Now we want to check the level of the electrolyte in each cell. A couple of things are very important about the level. Number one, you absolutely do not want to fill them up. That's the last thing you want to do. You don't want the acid overflowing out of the cell. And you can see in this cell here that the water level is perfect. There's a little slot on the side of the fill tube. And at the bottom of that slot is where we want the electrolyte level. Let's take a look at a cell that's a little low. You can see that the water is not quite up to the bottom of the fill tube. You can see the bottom of the fill tube is just above the surface of the electrolyte. And we can also see the plates down through the electrolyte. Very important that you never allow the electrolyte to drop below the level of the plates. That will permanently damage a battery. But this cell right here is slightly low. Any cells that are a little low need to be brought up to the bottom of the filler tube. And so we're going to put a little bit of distilled water into our cup. Now you can use a cup like I do. You can use a small funnel. You can use one of those turkey basters that you buy at the auto parts store. The trick is to get the water level right and to make sure you're using clean, distilled water only. Be very careful not to splash when you're doing this. Again, wear gloves and eye protection and go slowly. Once all your cells are filled right to the bottom of the filler tube, you can go ahead and replace all the vent caps. If your batteries are located such that you can hose them off or rinse them off, now would be a good time to do that. Just be sure never to use a power washer or high pressure water on your batteries. So all 12 cells in this battery bank are in great shape. But what do you do if your batteries are fully charged and they're showing low on the hydrometer? What happens with deep cycle batteries after many cycles where they've been drawn down and charged back up and brought down and charged back up is something called sulfation. Sulfation is where the sulfates in the acid that are supposed to be in suspension in the liquid attach themselves to the lead plates. And once they've done that, they're no longer able to function properly, and you will have reduced functionality from your batteries. Over time, if you don't do something to get rid of this sulfation, your batteries will become useless. To improve the performance of your batteries and prolong the life of the batteries, we're going to show you how to do something called equalizing, which gets rid of the sulfation. To do an equalized cycle, you have to have an RV equipped with an inverter charger with an equalize feature or solar panels with an equalize feature. It's a function of the charger to perform the equalize cycle. And what an equalize cycle is simply ramping up the voltage higher than usual and basically boiling the sulfates off the lead plates. Instead of the usual limit that a charger would put on putting power into the batteries, the equalize cycle is going to ramp them up considerably higher, up to about 15.5 volts. Now, as part of doing that, we have to make sure that we don't damage anything in the RV that would be harmed by such high voltage. The main things to be concerned about are your refrigerator circuit board and your air conditioning circuit board. Those run off 12 volts. So we're going to not only turn the refrigerator off, we want to pull power to the refrigerator and to the air conditioning unit. Now in this RV, there's a single fuse that we can pull that sends 12 volt power to the refrigerator and to the air conditioning unit. We're going to take that fuse out to make sure we're not going to send high voltage into the circuit board of the refrigerator or the air conditioner. So we've pulled that fuse, and that protects both the refrigerator and the air conditioner. You want to make sure that any other high-tech equipment you have on board that runs off 12 volts that might be susceptible to being damaged by high voltage has been disconnected from the system. If you have a battery disconnect switch for your house batteries, disconnect them prior to equalizing. Now the equalize cycle normally runs for 4 hours. So you're not going to be opening your refrigerator during this time. You're not going to be running your air conditioner during this time. If your RV is equipped with an inverter charger with an equalize feature, you can command the equalize cycle to start right from your control panel. Now this RV is not equipped with an inverter charger, and the only way to do an equalize cycle on the batteries is by using the solar panels, which is fine. And you'll notice that this controller has an equalize cycle available on it. Now the reason the light is blinking on the solar boost controller is because the batteries are currently fully charged. We're going to switch over to battery voltage mode, and sure enough you can see they're being held around 14 volts. But for an equalized charge, we want to boost up over 15. So all we're going to do is take the point of something sharp like a pen, and we're going to push the equalize button and activate the equalize mode. And that rapid flashing light indicates that we're in equalize mode. And you can see the voltage is now being pushed up to 15.2. 15.2 to 15.5 is about the range that you'll see on an equalize cycle. And we are going to run this cycle for 4 hours. And by putting that high voltage into the battery for 4 hours, we are going to boil the sulfates off of the lead plates and put it back into suspension, into the battery acid, into the liquid where it belongs, so the batteries can do their job correctly again. After we've done the equalize cycle for 4 hours, we'll again turn off all power and all draw on the batteries and let them rest for about 30 to 60 minutes. And we'll do our hydrometer readings again. If you recall, the purpose of doing the equalize cycle was for batteries that did not read 12.78 when we did our hydrometer readings. After we run the equalize cycle, we'll do another set of hydrometer readings on all the cells, and they all should have come up. If the cells are still not reading about 12.78 on the hydrometer, we'll run the equalize cycle one more time for a total of 8 hours.